All right, so in this video, I'm going to explain how to find local maximum and local minimum using the derivative. So if we have a parabola, we know we can find this minimum point, which is called the vertex, using this formula here, x equals negative b over 2a. So we're going to do that first. And so b is 4 and a is 2. So if we plug it into the formula, we would get the x coordinate equals negative 1. And then to find the y coordinate, we plug it back in to the function for x in both places, and we get y equals negative 10. So the coordinates of this vertex are negative 1 and negative 10. And that's a review from algebra, and we did that earlier in the semester. But now we're going to learn a different way using calculus. So dy dx, the derivative of this function, would be 4x plus 4, because we just do 2 times 2 is 4. And then you drop the power by 1, so it's 4x to the first power. And then the derivative of 4x is just 4. The derivative of negative 8 is 0. So there's the derivative. And now the derivative at this specific point is going to be 0, because the derivative is the tangent line to the curve at that point. And the tangent line to the curve at that point has a slope of 0, because it's a horizontal line called a horizontal tangent. So if we set the derivative equal to 0 and solve for x, we will get the same thing we got before, x equals negative 1. And then we can still plug it in to find y. Now, the reason this formula is the way it is because of calculus. You can see on the next slide, before we go on. Yeah, in general, to find the maximum or minimum point of any function, we're not just going to do parabolas, you find the derivative, set it equal to 0, because there will be a horizontal tangent line at that point with a slope of 0. And then solve the equation for x, and that will give you the x coordinate. So where did this formula come from? If you take a standard form of a quadratic equation, ax squared plus bx plus c, and you find the derivative, dy dx, you would get 2ax plus b, because we do 2 times the constant in the front. A represents a constant number. So we do 2 times a, then times x, and we drop the power. 2 minus 1 is 1, so 2ax to the first. And then the derivative of bx is just b, and the derivative of c is 0. And then we set that equal to 0, and we solve for x. So the first step would be to subtract b on both sides, and then divide by 2a. And there is the negative b over 2a. Okay, so does this work for other functions? Yes. If we have a cubic function where the highest power is 3, then we get this little squiggly curve going infinitely in both directions. And we get this point A, which is called a local minimum. It's not the absolute lowest point that the function goes, but it's kind of a little bump that we call the local minimum. So if we do the same thing, we find the derivative of this function, 3x squared minus 4x, and we set it equal to 0 and solve for x. We could add 4x to both sides like this and cancel it out here. And now this next step's a little bit tricky. Divide both sides by x. If you divide by x, this x completely cancels out. This one, there's still one left here. And then divide both sides by 3, and that will be the x coordinate of a. So this point has, it's about 1.33. Okay, and then to find the y coordinate, we plug that in for x into both spots. So I do that here, and we get, sometimes we get some weird numbers with these cubic functions. So the y coordinate will be negative 1.185 if you plug in the x into the original function. So we have coordinates 1.3 repeating, and negative 1.185. And I'll want you to write your answers as coordinates x comma y, like that. Okay, one more example I have for us is a fourth power function and a local maximum. So now we want to find this point right here, and so we just do the same thing. Because there will be a horizontal tangent line with a slope of 0. So if we find the derivative at that point, it's going to be 0. So derivative here would be negative 8x cubed, because 4 times negative 2 is negative 8. Drop the power by 1, and then 3 times 3 is 9. Drop the power by 1, and this has a derivative of 0. Set the derivative equal to 0 and solve for x. So we'll move the 9x squared. So I'll add 9x squared to both sides, and then divide both sides by x, and then divide both sides by negative 8. And so there's the x coordinate of this point, and you can kind of see that makes sense. Here's 0, and here's negative 1.125. Okay, and then the y coordinate, again, just plug it in to the original function. And I would definitely use a calculator, a TI-84 style calculator to get this point, and this is a rounded off answer, about 3.068. Okay, so that's how we use the derivative to find local max and local min points of functions.